Hello everyone, welcome to the NN classroom. Today I'd like to share with you another specimen question extracted from the paper 1, that is question number 37. What is it asking? Which compound has two enantiomeric forms? First of all, the idea behind is be able to know what's meant by enantiomeric forms. Two enantiomeric form means it is able to form the concept of enantiomers. Enantiomers is a really important concept that coming from the organic chemistry topic 20. When forming enantiomer, the fundamental condition behind is that compounds, especially carbon that we are majorly considering, is having a chiral center. I can say chiral carbon. Be able to have a chiral center is the number one criteria in having a pair of enantiomers, right? And the criteria of having a chiral center is fundamentally one of the carbon has to bond with 4 different groups. So that means now the question is broken down as which of the following compound does one of the carbon bonds to the 4 different groups? If that is, then we expect that compound will have the 2 enantiomeric forms, right? So in this case, if we scan through again based on the condensed formula, a faster way to look for whether we can see any carbon has bond to 4 different things is that if you see the carbon next to it bonds to something that's being repeated, just like this, you see C bonds to 3 of the edges. Obviously, it's not going to be carbon that is chiral, because you can see 3 hydrogens, repeated hydrogens, are bonded to carbon. So that's why from this perspective, this carbon is not chiral. Similarly, C bonds to 2 hydrogens adjacent, so that shouldn't be, right? And C, although bonds a different element, but still repeated as bromine. So 2 bromine bond to this carbon, sorry, no, and CH3, no, right? So in this case, A is not a choice, right? If you scan through it, you'll realize that for B, this carbon, no, because 3 repeated. This C, 2 repeat hydrogen. But for this carbon, you see one of them is a hydrogen, one of them is a bromine, one of them is the next adjacent carbon, that is CH3, and the previous adjacent area is a CH3CH2. So in this case, this carbon is going to be a chiral center, as it fulfills the condition carbon has bond to 4 different groups. So in this case, we better put a star that indicates this carbon is a chiral center. So one chiral center will able to form 2 enantiomers, so it means 2 enantiomeric forms, right? So that's why the answer goes to B. But students can also realize that in C, they can easily realize that, well, those carbons are all repeatedly bond with hydrogens, right? But for D, there's a one carbon that is pretty similar to the choice of B, right? And people are always suspicious that will this carbon be chiral? But if you look really carefully, you'll realize this carbon, yes, first bond to 1 single hydrogen, next bond to 1 single bromine, but the thing is, adjacently, 2 more groups of carbon adjacent directly linked to this carbon are of the same pattern, that is CH3 and CH2, both bond to this carbon. So meaning that 2 of the groups are going to be the same, unlike this, right? From B, one of the carbon chain is a CH3-CH2 area. One of the carbon chain that bonds to this carbon is just CH3. So that's why that is different. But this one is the same. So that's why we cannot choose D as the chiral center, no. But the answer goes to B.